And good day, folks. Sorry for no beeps. I was muted, but we're good to go now. We're going to cover CO3 today, which is applying the midpoint formula. And so we're going to go back to the coordinate plane and look at how to get the midpoint of a segment. Why does it have to be a segment that we're trying to find the midpoint of? Let's start there. Why does it have to be a segment that we're finding the midpoint of, Drake? Right, because in order to have the middle of something, you have to know how long it is. And because a line has no measurement, you can't measure it. It goes on forever. Ray, similar thing. We are stuck dealing with segments. So this is not anywhere on your binder sheet if you're trying to find it. If you want to take these notes down on the back side of a page or whatever, feel free, but they're not required. I'm going to put a segment up on the board here. Let's just kind of start a little bit basic here. Let's go with 2, 1, and 5, 4 as our endpoints here. Okay, what's the midpoint of that segment? And midpoint is just a way to say the ordered pair, the point that's in the middle of it. Okay, and be prepared to tell me how you found it also. What's the midpoint of that segment? Blake? 3, 3. Okay, now how'd you come up with that? So visually, you can see it's in the middle, right? Who else has got another? Other people that had their hand up, and we're going to say 3, 3. How did you know, other than just looking at it? Yeah. It was right in the middle of the line. So you just kind of looked at it. Okay, good. Do you know? So it's 5, 4, and 2, 1, right? The ordered pairs are 1, 2, and 5, 4. This ordered pair here is 1, 2, and this ordered pair here is 5, 4. Okay? Sydney? 3 is in between 1 and 5, and 3 is also in between 2 and 4. Yes. Okay, so if we're not gonna, Gino, you were on the right track here with looking at the ordered pairs, because if we're not just gonna look at the segment graph, because if you look at CO3, there aren't any segments graphed on that page, right? They're all given ordered pairs to you. So what Sydney's saying here is, if I don't have the graph to look at, I look at my 2 x values, 5 and 1. What's in the middle of 5 and 1? 3 is, right? 5 is 2 greater than 3, 1 is 2 less than 3. If I look at my y values, 4 and 2, what's in the middle of 4 and 2? 3. Where's 7 coming from? 3, right? 3 is 1 less than 4, and it's 1 greater than 2. Okay? Shh, we're done. All right? Let's look at a second one here. Whoever's Squeaky McSqueakerton, stop that, please. Let's go with -6, 4, and 4, -4. Let's make this one a little bit longer segment here. See if I can connect this with a straight line. Is that good?
It's a parabola.
That was not my best work. Yeah, okay. Let's what's in the middle here? What's the midpoint of this segment? How far off is my line? Michael? So looking at 0, 0, do we agree with that? It does go right through, yes. But I mean, does that point look to be in the middle of our 2 endpoints? Okay. Let's use Sydney's idea here instead, where we've got our ordered pairs -6, 4, and down here we've got 4, -4. Okay. Take a look at our x values. What's in between -6 and 4? What's in between -6 and 4? Drake? -1. How'd you come up with that? Shh, boys. What's that?
Between 6 and 4 is 1, and because -6 and negative,
Okay. Okay, so -1 you're getting for our x value there. What's in between 4 and -4? 0. So mathematically, we find the ordered pair, oh boy, -1, 0, which if we, I'm really bad at drawing lines. I'm horrible at drawing lines. Now that we, warning for you. Now that we have these ordered pairs plotted, though, how could we, my poor line drawing skills aside, how can we further prove that -1, 0 is the midpoint of that line? What else could we use here? Drake? Add 5 to 6 and take away 5? Where's 5 come from? Oh, you're saying add 5 to -6 to get to -1 and add 5 to that to get +4. Is that what you're saying? Okay, yes. You're kind of getting at where I'm going, which is slope. If we look at the slope of these lines here, okay, you're going down 4 over 5. This is another down 4 over 5 to get to that next point there. So because the slope between the two endpoints and the midpoint is the same, we can also kind of mathematically prove that midpoint is in the middle, right? But the objective says, Michael, warning for you, the objective says we're looking for a formula here, okay? We're looking for a formula here. This is the background to it. It kind of explains why the formula works, okay? Think of how you find the middle of something. You do it on every other math packet. What 3 middles are there to a set of data? It's usually the second to last page of your math packet. Mean, median, mode, right? This middle, which one of those 3 is it? Is it the mean of the ordered pairs, the median, or the mode? James? It's the mean. What's the formula for finding mean again? Peter? You add them up and divide by how many there are, right? How many endpoints does a segment have? 2. So how many x values of endpoints does a segment have? 2. So if we take, back to our first one that actually looks good here, if we take our 2 x values, 5 and 1, and add them and divide by 2, what do we get? If we take our 2 y values, add them, and take the average, divide by 2, what do we get? 3. Game changer, exactly. It'll even work on our McDonald's straw, as Joe so accurately labeled it here. If we take the 2 x values, folks, if we take the 2 x values of our endpoints, -6 and 4, add them together and divide by 2, what do we get? -1. If we take our 2 y values, add them together, and divide by 2, what do we get? 0. Okay? So, the midpoint formula is essentially you finding the average of your x coordinates and your y coordinates of the endpoints. Let's go back to our page here. Okay? The midpoint formula is essentially the average x1 plus x2 divided by 2. Okay? The average of your x values of your endpoints, meaning you add them together and you divide by 2. The y coordinate of the midpoint is the average of your y values. y1 plus y2 divided by 2. Okay? This is given to you in the notation of an ordered pair because the midpoint is an ordered pair, right? It's a location on that segment. Okay? The x coordinate comes from the average of the x's of the endpoints. The y coordinate comes from the average of the y values of the endpoint. right? So we didn't actually define midpoint here. We'll do that here. A point in the middle of a segment. A point in the middle of a segment. So down to Mr. Happy Pencil there. Obviously, this being a formula, key point, I recommend it going on a help sheet. This would be a possible question on your postulates, theorems, definitions, properties, formulas test. And so, again, I recommend keeping like a running log of all this stuff so you know what to prepare for. At least highlight this so you know that it could be on any of those quizzes, which, by the way, are pop quizzes. So they could happen any time. I could stop recording right now and give you one. That's up. I'm just kidding. Yeah, you probably could. Since there's only like one thing that could be on there, or two if you include this app. Anyway, so find the midpoint of the segment with endpoints A and B. We care about these endpoints, and we label them kind of like we did with slope, right? When we had that slope formula, we had x1 and y1 and x2 and y2, okay? Only we're using them in a different way. The average of our x values, 2 plus negative 5, divided by 2. And the average of our y values, negative 3 plus 6, divided by 2. What does that give us? 2 plus negative 5 divided by 2. Negative what? Not 1/5. Drake? Negative 1.5. Okay? No, you're not. And then negative 3 plus 6 divided by 2? What does that give us? Positive 1.5. So the midpoint of that segment is at negative 1.5, positive 1.5. Okay? Hopefully you can do this addition and subtraction and division mentally. If you use a calculator, however, why do you need to be careful? Mackie.
If it's a negative, don't hit the minus sign, hit the...
Sure, yep. If it's a negative value, it's not the minus button, it's the negative button. That would throw you off. What else? Drew? You've got to use parentheses. If you put in your calculator 2 plus negative 5 divided by 2, what's your calculator going to do? Michael? It's going to do the division first, exactly. Okay, so if you're going to use a calculator, make sure you're putting parentheses around that 2 plus negative 5 so that you're doing that first and then dividing by 2. Okay? I'll let you do the next one on your own. And then going down the page a little bit, it says, surely there's a part of you that has always wanted to be an architect. Design a town on the coordinate grid below. Your town should include a library, point L at 3, 6. So we're going to label 3, 6. This is point L. Okay. A church at negative 9, 4. Got to have a church. Okay, there's our church. A school at 0, 8. Must be educated as well. 0, 8, there's our school. And City Hall at 5, negative 4. And we call that point H. Okay. So in order to do this correctly, you've got to put your coordinates in the right spot. So I'm kind of helping you out here. And then the questions that you need to answer. What is the midpoint between the library and the school? What is the midpoint between the church and City Hall? What is the midpoint between the school and the church? And then for Brainbuster down here at the bottom, it says, what is the endpoint of segment AB with point A being negative 10, 6, and the midpoint being 14, negative 2? So in this last one here, I'm giving you one of the endpoints, and I'm giving you the midpoint. How do you kind of work through the formula to get the other endpoint of the segment? Okay? I'm going to leave you to think about that, right? So understand what the formula does, how it gives you the midpoint. If you're given different information, how can you use this to get the other endpoint? And you don't have to use the formula necessarily. There are other ways, but the formula is kind of the focus. And this is one of those objectives when your homework is only on this page. There's nothing more for you to do, okay? So this is due tomorrow. I'm hoping, anticipating the number game, yes?
Yes, we are.
All right. That's how math, folks.